The Moon, as we see it today, is a barren, airless world, covered in dust and craters. Its surface is exposed to the vacuum of space, with no atmosphere to protect it from the sun's radiation. But what if the Moon wasn't always like this? What if, billions of years ago, the Moon had an atmosphere, one thick enough to resemble Earth's? Scientists now believe that for a brief period in its history, the Moon was not as lifeless as it seems today. Instead, it may have had an atmosphere created by violent volcanic eruptions. Lava once flowed across the lunar surface, spewing out gases that formed a temporary atmosphere. Could this mean that the Moon was once more Earth-like than we ever imagined? The Moon formed about 4.5 billion years ago, likely from a colossal impact between Earth and a Mars-sized body. In its early years, the Moon was not the cold, dead rock we know today. It was geologically active, with powerful volcanic eruptions shaping its landscape. The dark patches we see on the Moon, called lunar maria, are vast plains of solidified lava. These plains formed when molten rock burst from the Moon's interior, covering vast areas. During these eruptions, enormous amounts of gases were released, including carbon monoxide, sulfur dioxide, and water vapor. This outgassing created a temporary atmosphere that was much thicker than the Moon's current exosphere. How do we know this? Lunar samples brought back from Apollo missions contain traces of volcanic activity. Analysis of these rocks reveals that some minerals could only have formed in the presence of an atmosphere. Additionally, satellite observations have detected remnants of ancient volcanic vents and lava tubes. These findings support the idea that a significant amount of gas once surrounded the Moon. At its peak, this lunar atmosphere may have been even denser than that of present-day Mars. But how long could it have lasted? Unlike Earth, the Moon lacks a protective magnetic field. Earth's magnetic field acts like a shield, preventing solar wind from stripping away our atmosphere. Without this shield, the Moon's atmosphere was vulnerable to solar radiation and space weather. Over time, charged particles from the Sun eroded the Moon's atmosphere, causing it to slowly escape into space. It is estimated that this atmosphere persisted for 70 to 100 million years before it completely disappeared. As the Moon cooled, volcanic activity subsided, cutting off the supply of new gases. Without an active source replenishing the atmosphere, it became too thin to sustain itself. What remained was a near-total vacuum, much like what we see today. However, some of the water vapor released by volcanoes may not have escaped entirely. Instead, it could have settled into permanently shadowed craters near the lunar poles. In these regions, temperatures remain so low that water ice can survive for billions of years. NASA's recent lunar missions have detected frozen water hidden in these craters. This discovery suggests that at one point, the Moon might have had a functioning water cycle. But could the Moon's lost atmosphere have supported life? Even at its thickest, the lunar atmosphere was likely too thin to support complex life. However, some researchers believe that microbial life could have existed in underground lava tubes. These tunnels, created by flowing lava, could have provided shelter from cosmic radiation. If conditions were right, these environments could have been similar to deep-sea hydrothermal vents on Earth. If microbial life ever developed there, traces of it might still exist today. Future missions could explore these lava tubes, searching for signs of ancient biological activity. If life once existed on the moon, it would change our understanding of habitability in the solar system. This leads to an interesting question: could the moon's atmosphere ever be restored? Some scientists believe that, in theory, it could be possible to artificially thicken the moon's atmosphere. One idea involves releasing gases trapped in the lunar soil to create a breathable environment. Another proposal suggests importing ice from asteroids or comets to generate a stable atmosphere. Such projects would require massive technological advancements, but they aren't entirely impossible. Terraforming the moon might one day make it more suitable for long-term human habitation. If scientists can understand how the moon lost its atmosphere, they might also discover how to bring one back. NASA and private space agencies are already planning future lunar bases. These bases will rely on extracting resources like water ice for survival. Studying the moon's ancient atmosphere can provide crucial insights into building sustainable habitats. By understanding how its climate evolved, we can better prepare for life beyond Earth. This research also helps us learn more about other moons and planets in our solar system. Many moons of Jupiter and Saturn have thin atmospheres that could resemble the moon's past conditions. Studying the moon's lost atmosphere could provide clues about how atmospheres evolve across the universe. Ultimately, the moon's history is still being written. What was once thought to be a lifeless rock might have had a more dynamic past than we imagined. Though it no longer has a thick atmosphere, its history reveals a fascinating chapter of planetary evolution. And as technology advances, the moon may once again play a crucial role in humanity's future. Perhaps one day, we'll not only walk on the moon but find ways to give it an atmosphere once more.